Hello and welcome to CSE Core Concepts in the series of UML diagrams. In this video, we are going to discuss about a deployment diagram. So let us first understand what is a deployment. So what do you mean by deploy? That means making a software application or updates available for use by the users on a target system, let's say either on a production server or the user's device. When you are going to update any app or you want to install any app, right? So it is used to visualize the topology of the physical component. So you will understand the topology. What is the topology? The network, that how one component is attached to the other component. Now, this consists, you can have nodes, you will understand the relationship between them, what are the different hardware components used and how they are connected, etc. So if I have a software, I want to deploy in some server, right? So that server is my hardware component. So now you will have a question that, ma'am, this all we have done in the component diagram, that is joining the nodes and the components. So how they are basically different from each other, that is they are closely related to each other. The component diagrams are used to describe the components only, that is the files only, right? Artifacts, files, executables, libraries, that way. But the deployment diagrams are deployed in the hardware. So they are shown inside the hardware how they are applied. Okay. So this is how it is done. So it helps to deployment diagram will help to plan the software system which will set up on different devices. They design the hardwares which are required to support the software, and it will discuss that how which software will go where, how they are connected in the network. So they make sure that each part of the software has enough resources like memory, processing. So this is like a outer plan before you create a software. No, before you start making a software and you deploy. So you make a plan, right? You perform an analysis. So in that plan, you are going to find out, like say you are making a application for a student system. And now that can be used by the teachers, that can be used by the administration, by the students, everything. So you are going to plan out, okay, this type of what are the files you will require, which files are connected to whom. So you identify the components, and then with the hardware, like this is my application server, this is my main server. In this main server, these are the files which will be there. In the application server, these files will be there. This software will be installed here. On the user's device, what software portion will be installed. So it gives you a complete layout or the topology of all your system resources, be it software resources, be it hardware resources, and where they are kept, right? So let us see the elements first of all quickly. So all the elements are more or less same as that of the component diagram only. So no major difference is not there. So first of all, we have 3D boxes. They are called as nodes. So these nodes can be your hardware device, your workstation, your computing resource, your application server, users mobile phone, laptops, whatever hardware devices you want to show, server, etc., you can show it using represent it using the node. So it is a box with the rounded corners. Now this box is there, but the corners are a bit rounded, and in between you have to write the name, and you can have hierarchical structures also, right? So you have the main server has two sub servers and all, understood? So these nodes can have an hierarchical structure also. Then of course the components. So these components are representing you the software modules or the artifacts. Okay, so artifacts are what we have seen in component diagram. In case if you have missed the video, please go through that. The artifacts are your executable files, libraries, database, configuration files. So they represent the modular. So when you break down your software into small portions, so each module can be represented using a component, and they are reusable like classes, etc. So they are encapsulating the behavior of the data which you require, and the functionality, and they are represented with a rectangle and two small rectangles protruding from the sides. So this is how the component looks like. Then you have the physical files which are placed on the nodes, which are called as artifacts. So it is simple, just a folded, like we fold the side of the page, no? So a small triangle which represents as if the page is folded. So they can be your executable documents, jar files, jar.exe files, etc. So it has a folded corner. Some file extensions also you can include, like so, abc.java or .jar, whatever type of file. Dependencies, they show the relationships. We have been discussing about dependencies. So this dependency is depicted using this arrow, and a web application depending on the database component, let's say. So this is shown using a dependency. Then dependency, your association relationship can be associations. So association means you have a communication path. This device is connected to three other devices, like this also you can show. So mapping of the software components on the physical nodes. And comes your interface. They are simply represented by a circle or an ellipse. Okay, so they represent the point of interaction, the way we discussed in the component diagram. So let us have a look at how does your deployment diagram looks like. So you can see these 3D boxes. They are your physical representation. So you can say this is the bank server. This is a communication between a buyer to a real estate person. Let's say online we buy real estate like 99 acres or any other. So let's say for example I am going to book or do something work, and maybe I have to do some payment, and also I require the bank also in my loop. Okay, so we have three servers interacting with each other: the real estate company's server, my personal PC, okay, from where I am using maybe laptop or whatever, and you have the bank server, right? So you can see the interfaces over here. First of all, see this PC is connected to using the TCP IP, that is internet. Again, we are connected to the bank within the TCP IP. So this is relationship is an association. Understood? Then say for example, we have this, let us have a look at this PC component. So PC component has only one component, that is the buyer interface. The HTML or whatever file we get, no, we have that interface where from where we search houses or post advertisement that way. So this now you can go to the real estate server. So real estate server has two components, listing and multiple listings. So they are dependent. Okay, so one listing which is done is dependent on the multiple listings. So this is a dependency relationship, and this is interface is there. This interface is connected to the mortgage interface, right? So let's say it is a mortgaging. I am mortgaging for some money. Let's say these are mortgage applications and customer database. So customer database and mortgage application, so there is a dependency. If customers are not there, then mortgage application is not available. Understood? If that customer is not there. So, and these are the components, and this is the interface, and each of them are represented as nodes. So you can see an interaction between the bank server, the real estate server, and the PC of the buyer. Next is your another diagram. You can see, let us say I am having we add the bank application, no, bank apps, right? SBI, ICICI, how they work. Let's say in your mobile. So your mobile has isn't, let's say, an Android device. So inside that Android device, what you do is that you have the bank application or the app which you download. You download it using the web services, whatever internet, Wi-Fi service you have. Now, when you download the app, you are connected to the application server. So from that application server, you get so many components. Components means each one of them is a separate module. Like you can have, you want to see your statement, you want to do fund transfer, you want to do check transfer, other services. So each of them are individual components. Now these components are using the data storage. So data storage is another hardware component where I have the tables or the database stored, account detail table, customer table, and all are connected via the interface. So fund transfer. So fund transfer is connected to the account details. When you see, right, check transfer, it is connected to the account details. Other services is connected to the account details. Statement preparation is connected to the account details. And account details and customer details are connected, right? If you want to see the account details, you have to give input the customer details. So this is how you are showing your hardware component, and in which hardware component, what software components. So you are showing that the app which you have prepared for the client, it is on the client's device. The app with the various files or the services which you are providing is on the application server, and the database is stored separately. See, in your case, database might be in the same server also. So in that case, you can show it inside this server only, right? And you can show the connection like this. So I hope you understood the deployment diagram. Please go through it and solve as many case studies as you can. Now this is something like that. You do not have a fixed rule that this is only to be created or this many modules. This depends on the type of the application and the functionalities which you are providing in your software. So of course it varies. So I can just give you some examples, case study to understand the concept. Rest you have to prepare it on your own understanding based on your system. So if you understood, please do press the like button and don't forget to share and subscribe to CSE Core Concepts. Thank you.